Finally, we're going to look at the last piece for this quarter, well, for this week and for the entire quarter for this class. The cell system. Now, the cell system is a WAN technology, of course, but it ties into the standard telephone system, the plain old telephone system or public switch telephone network. It just uses these bridges from the antennas and then the infrastructure to the public telephone system. It is able to carry both voice and data, well, at least today's is. 1G, or first generation, was only voice, and it was all analog, no digital, no digitization at all. 2G, or second generation, did carry digital voice rather than analog voice. No data was actually sent out at that time. It used time division multiple access, which you may remember from an earlier lecture, how that worked. I'm not going to go back into it again, but we did cover it in our course. 2.5G came out. What that added was SMS. So now we actually had text. We could do voice and we could do text. So that was the first time we were able to actually do data. We couldn't do the internet yet. 3G, about 200 kilobits per second data rates. You had a couple of options for these data systems, Gsm and Cdma. Now, Gsm was used by a couple of the carriers, and Cdma was used by a couple of the carriers. Basically, Gsm was used around the rest of the world. The United States used Cdma quite a bit, which was actually an older and not as good a technology. So we really kind of had a choice at that point. And then 4G came out. Now, 4G was not actually 4G. It's kind of funny. It was actually 3.9G with LTE. The reason I say that is because 4G, by definition, has certain data rates that it requires us to hit, and we never did hit those data rates. And so we actually called it 3.9 plus LTE, and so then the name 4G LTE is not true 4G, it's just 4G LTE, which is a phony name, right? It does use this LTE, and I'm not going to go into how LTE works. It's kind of fun. We do that in another course, the wireless course, but I'm not going to do it here. About 6 megabits per second. Now, these are theoretical speeds, by the way. You're never actually going to reach these speeds. In fact, you're going to reach less than half of the speed. There's some reasons for that. Again, I'm not going to go into it. 5G is coming. I said coming to a street lamp near you, and that's because you just can't go very far. This is a very high frequency type of signal, and remember, high frequencies don't go very far. They're blocked by nearly everything, and in the case of 5G, it's blocked practically by window glass. So it doesn't take much for it to block these higher frequencies. So it's going to require a lot more antennas than we have now. About 300,000 antennas have to be installed. That's more, as I put here, than we have produced in the last 30 years combined. However, 2 gigabits per second. That's crazy. As a matter of fact, we might even be able to get up as far as 10 gigabits per second. Again, theoretical speeds. Now, because the speeds are so great and because there is a bridge from the cell system to the internet, it's possible that ISPs could lose some business and that the telephone companies could be our new internet provider. So it'll be interesting to see how that works. Here's a 5G antenna, by the way, on a light post. This is what we're likely to see all over the place with 5G. We're probably also not going to see 5G outside of large metropolitan areas. So you get out in the Midwest, whether you just have a range of hundreds of acres or thousands of acres between houses, you won't be seeing 5G there anytime soon. That's it for this course. That's the end of these notes, and I thank you for watching, and I thank you for listening, and I thank you for being in my class.